Today we're talking about boilers. Very exciting. Okay, what a boiler is that in most factories they don't cook food with a pot with fire underneath it. That's not the way they cook. They cook with steam or with hot water that's made by steam, and that means is that someplace deep in the bowels of the factory there's a boiler. Okay, what's a boiler? Basically it's a big, huge tank. That water gets boiled inside of it and it turns into steam. You heat it up so far high with a fire, so strong, turns into steam. Steam gets pumped all around the factory to do the different kinds of cooking that is done with it. After the steam gives off its heat to cook the food, it turns back into water. It condenses back into water, and then that water flows back to the boiler. Usually, it flows back to the boiler where it gets boiled again, and the process continues. Okay, so a few hundred gallons of water in the system that keeps getting boiled and passed around to the pots, to the kettles, and then back to the boiler, around and around. That's how the cooking gets done. Now, there's two things that are relevant for us to know about for boilers, why it's negated to people in Hashgachah. One is that sometimes you can make food, if food needs to be Bishul Yisroel, you could do that by lighting the boiler. In certain kinds of devices, like ovens, you could maybe have a pilot or things like that. One day when we talk about pilots, we're going to see that doesn't really work for a boiler. It's not a realistic possibility for a boiler, for a big boiler. So we're going to talk today a little bit about that also, how you make Bishul Yisroel in the boiler. And the other thing is that, as I just said to you, that the water, the condensed water, the condensed steam, comes back to the boiler. So therefore, then there's potential for time transferring. If it cooks on the tray for milchigs, then it comes back and mixes in the tray. Okay, we're not going to talk so much about that today, except just I'll show you how the steam system works, so you'll see the shiloh much more in your face. But I'm not going to talk so much about that. Okay, a little bit about that. Okay. So now, I'm going to do something a little technical now, which I think makes sense to understand what's going on. Bear with me. Okay, there are basically two types of boilers. One's called a Firetube boiler, and one's called a Watertube boiler. Okay, what's the difference? So on the screen, you see in front of you here now a Watertube boiler. A Watertube boiler means is that in that chamber that I told you, what we call the boiler, is basically it's a big empty chamber that has a fire in it, and there's water in tubes. That's why I call the Watertube boiler. The water is flowing through the chamber in tubes, and as the water passes through, it gets so hot that it turns into steam. So it comes in the picture. It comes in on the bottom as water, and it passes through these tubes. Since it's in this chamber that's all hot, so therefore the water gets boiled, and when it pops out the top, it comes out as steam. Okay, so here's a picture. This is actually from a company of Hashgachah. It's what's called a firebox, which is basically, this is an empty chamber. Now it's empty, but it's an empty chamber. And in here would be burning this huge fire, and you could see around the edges the tubes that carry the water, that would carry the water. And as the water flows through those tubes, it gets hotter and hotter to the point that it boils, and then it comes out the top as steam. Okay, so that's a Watertube boiler, because like I said, the water is in tubes. And this is a Firetube boiler, it's the same idea, but it's the opposite. Over here, the fire is the heat of the fire passes through tubes, and the chamber is really a big like a vessel full of water. Really, the whole thing is full of water, and the fire is passing through tubes. The fire is in a spot, but the heat of that fire passes through tubes to heat up the water. Okay, think of a big pool of water that has pipes going through it, but in those pipes,
never heard of such a thing. Those tubes are like empty, so there's heat to go through.
Right, correct.
Not just pieces of metal that heat up the water.
No, they're not solid metal. No, they're empty tubes. Right, they're empty tubes.
So there's heat, fire over here. You have empty tubes where the heat goes.
So that's what a Firetube boiler is. Okay, there's two different ways to make boilers. They're both very common in factories. And the water in the Firetube, the heat of the fire, not the actual fire, the heat of the fire is passing through the tube and going through this big pool of water. Okay, so there's all these things running through it, and that makes the water heat up, and the water boils out again, turns into steam, and boils out the top. Okay. Okay. Now, to start up a boiler. Okay. To start up a boiler. If it's a very small boiler, even a medium-sized boiler, could take just a few minutes or an hour. So you put in the water, turn it on, and if it's a small little boiler, then it can heat up in a relatively short amount of time. And because of that, if a company really has a small little boiler or a medium-sized boiler, they could turn it off for the night. They could turn it off for the weekend. They could turn it off for, it's going to be Thanksgiving. They can close it down for a couple of days. Okay. So as you can imagine, for Bishul Yisroel, that makes things worse. Okay. But a big boiler, a more serious boiler, you can't do that. You don't just start it up in 1 minute. It takes quite some time to cool it down and then again to heat it back up. And Mamela, they won't turn off a big boiler. Okay, and a boiler can go, from almost a whole year. Once a year, it needs a boiler inspection, and they do some maintenance. So, but it could go for a whole year without ever being turned off. They might turn it down to low for Shabbos or for the night. Bishul Yisroel-wise, that's not going to make a difference. But they won't turn it off, which of course, that's good for Bishul Yisroel. That means is if the Yid turns on the fire, turns on the boiler, then the thing could stay Bishul Yisroel for months at a time. Okay, we'll talk later about what he has to do with that, but it could stay for a long time.
These are all natural gas powered, right?
I have no idea if they're all natural gas. You mean
What else would it be?
oil?
Oil.
I have no idea what powers it. Fire. It's a fire. What makes a fire? That I don't know. Okay. Now, in this is a little bit of difference between a water tube and a Firetube boiler, which is the water tube boilers tend to be faster to heat up from being cold. So that's my impression that I get, that they're easier they heat up faster. It has to do with the water being in the tubes with a lot of surface area. Somehow that makes it easier to heat it up. But to drain the boiler, okay, now I'll talk from the draining be'etzah, and then we'll drain for us. Excuse me. We would potentially want to drain a boiler because, let's say it was used for treif. We're cooking something treif, so now there are bleas of treif in that water. That's water that's floating around this whole system. So we want to drain the boiler so we could put in new water, meaning kosher water. Okay, power of kosher water. Okay, so we, in general, in a big boiler, you can't just drain all the water out. Okay, that'll ruin the boiler. The metal will get bent out of shape, and you can't just drain out the water. Nor could you fill it up with cold water to start either. Okay, the draining and filling is a whole slow process. So it's almost, again, in a small boiler, you could say they turn it off for the night. They turn it on and drain the water out, or cool it down a little bit, drain the water out. That wouldn't be a problem. But in a big boiler, then you're not going to do that. So now, when we're talking about a water tube boiler, it's very easy for us to flush it out, because when I say flush it out means make sure no condensation comes back. None of the condensate comes back. If no condensate comes back and the boiler keeps making steam, then it's producing steam. It's pushing the steam out. Nothing's coming back, so it has to take in fresh water from the outside, from the city, meaning kosher water, and you're flushing it out. You're pushing out all the treif water is going out, and new water is coming in. But when you have a water tube boiler, that's really easy. Because in a water tube boiler, the water goes it's a one-way street. Okay, the water goes in the pipe and out the other end is steam. So if there's make up a number, there's 200 gallons of water in the system, and you lose 10 gallons an hour, then it's going to take that many hours. You just push it all out. It's a one-way street. Okay, but in the Firetube boiler, it doesn't work like that. Because in the Firetube boiler, it's not a one-way street. It's a big pool of water. So you can't push all the water out, because what happens is, as you push, let's say there's 200 gallons in there. So after a quarter of that water's out, so now there's 150 treif gallons, so to speak, and 50 kosher gallons. The next 10 gallons are not going to be all treif gallons going out. They're going to be a mix of those waters. Okay, so it's harder to flush out a Firetube boiler. The water tube boiler, it's easy to flush it out. You just push the water out. As the new water comes in, it pushes out the old water, and it gets pushed out. In the fire tube boiler, it's in a big pool together. So when some of the water comes out, some of the new water that you put in there is also coming out.
I know I just came late, but in the pipes on the water tube boiler, is water, right?
Yes.
It's not the steam. On the horizontal ones, what's inside? It's some water. It's some water in there?
No, fire. That's what we call a fire tube boiler.
Oh, the heat.
Yeah, the fire in the tube.
The question is what's in the tube? Is the tube
Yes.
water or the tube?
Yes. So it's hard to flush a fire tube boiler when you can't just say, oh, if I put in 100 new gallons of water, I pushed out 100 gallons of the chafe water. It doesn't work like that because the 100 gallons of new water pushed out some old water, and some of its new water got pushed out also.
And Kashrus, if you have new water coming in, doesn't that water automatically become free?
No, because we talked about it. No, we don't. I forgot to tell you that because we've talked about it before. We don't say Hanan and boilers. We don't worry about Hanan and boilers. Okay. I forgot to mention it. It's down here, but I forgot to mention it. Okay. So how are we gonna figure out how long does it take to flush it out? Again, the water tube boiler, it's easier.
Which one is more common, or they're equally common?
Equally. So in the water tube boiler, it's easier to know. You have to figure just how much it does per hour. Okay, we could figure out from the boiler people how much water gets used per hour, and that's that many hours, so we push all the water out. Okay, in the fire tube boiler, we need to be a little smarter. Okay, so it turns out, you could skip this picture, it's not so important. Okay, it turns out that in order to figure out how long it takes to to flush the fire tube boiler, you have to answer me 3 questions. And the first one is a halacha question. We've talked about this. We'll talk about it again different times. There's this 10% rule. There are those people who believe that the water in the boiler is only 10% chafe. Some people think it's 100% chafe. That would be the obvious choice. And some people think it's just 10% chafe. So your first thing, you're going to have to answer me a halacha question, whether you think it's 100% or 10%. You don't have to answer that question now. You'll see later. That's just going to be a decision that's going to have to be made. Is the water considered 100% chafe or 10% chafe? Okay. That's my first question. The second and third question are technical questions. And that is, the second one is, how strong is the boiler? Okay, boilers are rated by horsepower. They're called BHP, boiler horsepower. So how many and so the people in the boiler room, the guys in the dungarees, those guys, they know the answer to that question. Okay, what's the boiler horsepower for my boiler? They'll tell you, oh yeah, it's this many horsepower. Okay, it's called boiler horsepower. Okay, that's the second question. And the third question you have to answer is, how many gallons fit into the boiler? Okay, that question, the boiler people don't always know the answer to that question. Sometimes that's a little more of a guess at how much it is. But if they don't know, you could be overestimate like this. Okay, you just take the the diameter and the length, and you do diameter times diameter, it's 2 pi r times whatever times 0.0034 will tell you the diameter times the length times 0.0034 will tell you how many gallons could in theory be filled if the boiler was filled up all the way to the tippy top and there was no walls, but that's overestimating how much it is. So in the example that I have here, if the diameter is 60 inches, so it's 5 feet across, and the length is 10 feet, is 120 inches, so 60 times 100 inches times 120 times 0.0034 tells us that the most,
What are the 2 60s?
the diameter of the boiler
is 60, then
60, diameter times diameter.
diameter times diameter, diameter squared.
No, not diameter squared. Diameter,
diameter squared.
yeah, so I don't remember why that's the cheshbon. I don't remember how that works. I have to dig back into my math over here. I don't remember why that's the cheshbon. Anyhow, maybe I'm wrong about that. Maybe it's, okay, I don't remember. Okay, whatever it is. For my example, this is what it was. If my example was wrong, it's not going to get to the next part. You'll have to believe me on the next part. Okay, now, so we have our 3 questions. Okay, so now I told you you're going to answer these 3 questions, and somehow that's going to magically tell you how long to do the boiler. And do the following. Okay, do the following. You have to create something called what I call a conversion percentage. I don't think that's a real name. That's made up. Okay, we do the following. The conversion percentage is you take the boiler horsepower times 4. Okay, that number is actually a number that's not a David Cohen number. That's actually a boiler people number, that tells you basically 1 boiler horsepower can boil 4 gallons of water in an hour. Okay, you can read here for the technicality of it. It's actually 4.14, but boiler people use that number. Okay, that the 4 is considered the amount of it's a ballpark number of how much it could boil in an hour. Okay, divided by the gallons. Okay, so those are numbers that we got beforehand. This is the second question, and that was the third question. I tried to color code it. This is the second question. That's the third question. So what happens like this: we have a boiler that has a 40 boiler horsepower, so we times it by 4, and we divide it by this boiler holds 259 gallons. Okay, this was a real boiler, actually. This is an example from a real boiler. Divided by 259 gallons tells us that it has this 61.8%, what I call a conversion percentage. Okay, what do I do with that piece of information? Now I have this boiler, 61.8% boiler conversion percentage, and now I have a chart. And the chart says, the chart is based on information from the boiler company and from a mathematician who helped me make a formula with something called Euler's number. I don't know who Euler is or what his number is. Somehow that magically helps you figure it out. And then I checked it by working in Excel. Almost like by hand, so to speak, figuring it out. Okay? So what happens is, remember, our boiler percentage was 61.8%. Okay? So it's in this range between 60 and 65. So that tells me that now, depending on how you answer that halacha question, if you think it's 10% or 100%, treif the water in the water. Either took 3.5 hours.
That's just an example. Maybe 30% too.
No. That's a halacha question. It's a halacha issue. Okay. If you don't know, I'll tell you about it later. It's just a halacha question, which is if it's 10%, according to the 10% rule, it'll take 3.5 hours to drain the boiler. And if you say it's 100% treif, then it takes 7 hours to drain the boiler. Now,
and this is getting below bittul level.
To get it to be batal b'shishim, yes. To get that, the amount of treif, you can't get to 0, literally, but the amount that would be left would be batal b'shishim.
Just looking under 1.6%, 1.6%.
Correct.
And I'm assuming it's not practical to just totally drain the boiler.
That's what I said before. You could if you want to, but that'll take hours and hours to turn off and turn back on. So this is what you're trying to do to flush it. So now, just before you leave, even if it says take 7 hours, 7 hours would mean is if the boiler ran straight for 7 hours. Okay, that doesn't mean 7 hours on the clock. 7 hours of the boiler running. Now the boiler might only run half of the time. Okay, it's not always producing steam every second. So, but it just gives you a feeling. You look at the plate. Okay, the plate is busy or less busy. So let's say 7 hours is what it would take of 7 hours of boiler running. Okay, so we'll run it for 2 shifts. We'll run it for a day, and that way we know we've pushed out all, we've flushed out all of our boil. Now, again, so depending on where it fits on the chart, is most boilers, I tried it with a bunch of boilers, are in the between 50 and 65% their conversion number. Okay, that's how it was. But it could be more or less, depending on the boiler, on the whole setup of the boiler, depending on how many hours it should take. Okay? Now you should know, before I was so mathematical, we used to think it took, just say a week, just to be safe. A week of flushing, well, just a guesstimate. But it turned out that it's really less than that. It could be, depending on how busy your boiler is, it may take more or less, you know? It doesn't help to do this when the boiler is closed for Shabbos. You can't say, okay, you know what, we're closed for Thanksgiving, so Thursday, Friday, Shabbos, Sunday, that's 4 days worth. Okay, yeah, but during those 4 days, basically the boiler did nothing. It just sat there doing nothing, you know? So it'll have to be hours of serious production, okay? That's something that has to be going on that we should be able to do, okay? Now, that's the end of the math for today. Okay, so let's move on now. Let's talk about how boilers are set up. I told you there's 2 types of boiler, but now let's talk about how boilers are set up. Maybe this is elementary for you, but I'll do it anyhow. Okay, and then it's like this. When the boiler when the steam comes out of the boiler, okay, it pops out into what's called the steam header. The steam header is this really big pipe, and in this picture it goes right to the kettle, but it's not true. Really, this header then breaks up into smaller pipes that each go in their own direction. Okay, so the steam goes from the boiler into the kettle or whatever kind of processing equipment is being used. The condensation that drains out, which is still warm, it's not hot, but it's still pretty hot. It's like more than 200 degrees. Usually goes back to either a condensate return tank, which is basically like what it sounds like, or to what's called a de-aerated tank, the DA tank. That's a tank where, as the name implies, they get the air out of it, because the air is not good for the boiler. Into that DA tank is, aside from the condensate return, you're also getting, I'm sorry, the picture got a little cutie here. So from the DA tank it goes back to the boiler. Okay, the water goes back to the boiler, but the DA tank also has fresh water being put into it and water treatment chemicals being added into it. Okay, that's where they get added in. So it's common that the DA tank will also have a steam line running into it or through it, because if you think about it, what's happening here is, let's say the water comes back from the tank at from the processing equipment at 212. Let's say it comes back at its when it comes back it's 212. But into it you have to add in city water, which is colder, so you don't.
What? Because you're losing.
Because you lost water in processing. In processing, steam got lost. So you have to add water in. When you add water in, that water is going to be cold. It's city water. So you don't want to shock the boiler. So they'll have a steam line running through the DA tank just to keep that water heated up. Okay, that's not so important to us. But anyway, so
I'm just curious. I always wondered how the condensate is not that return line is not full of water. So what pressure is there that's bringing the water back?
A pump.
What?
A pump.
Oh, there is a pump. Where's the pump? The pump is by the DA.
No, the pump is right over here.
That they're saying the water really collects on the bottom and then.
No, it drains out of the processing equipment into the floor, or in someplace low, it's jacked by gravity, and then goes to a pump that pumps it back.
Even if the pipe is not full of water, really,
it pumps it back.
Pump water and air
together. Yeah. Okay. Okay. So that's that's what a steam system looks like. If you weren't familiar with it, there's something called there's something like condensate return tank before the DA tank, but that's not so important to us. Okay. So now, when there are times. We're not talking about when or why, but there are times, that you need to taste the water in this system to see if the water's problem. So, depending on what your sheet is, will depend, which we're not going to talk about today, is where you want to taste that water. If you want to see that the water is pogum even in the processing equipment, if you want to see that, then you need to taste the water, the condensate itself, okay, before it gets into the DA tank. In the DA tank, they're adding more chemicals into there. So if you want to see if the steam itself has any tam lefgam, then you need to take from the condensate return, okay? You have to find a place to drain that water from the condensate return and taste that water. Okay, but if you don't want to, if you're saying I just want to taste water in the boiler, okay, that's before it turns into steam. I want to see if that water is pogum. So now I'm going to tell you there's 3 ways to get water out of the boiler, okay? And I'm going to try to point you to the one that I think is the right way where to take the sample from. And the first is like this. Here, I'm going to back up because some pictures too distracting. Okay, the first is like this. When you have a boiler, you see here that you're adding chemicals into that water to make whatever they have to do jobs to keep the boiler safe, okay, to keep the boiler happy. So those chemicals cost a lot of money. Okay, so they don't want to add chemicals if they don't have to. So what they do is they find that most of the junk that collects in a boiler, or things that they don't want, they call dissolved solids, okay, TDS, total dissolved solids. The dissolved solids either float to the top or sink to the bottom, most of them. So what they do is like this. They have something called blowdown, surface blowdown, which is they every once in a while will continuously suck water off the top of the boiler. The boiler is full to here. There's a little drain sucking water out of it on the top, figuring that the most junk is collecting up there, and that goes to the drain. The point being is it's cheaper to just suck out that water and heat up new water rather than putting chemicals.
Honestly, they're putting in chemicals. Why are they sucking and taking it back out? They want the chemicals in there.
Right, but
before they put the chemicals.
No, the chemical.
The guys at the same time, but.
Right, they're saying is if this water, if for this much junk we would need a gallon of chemicals. If I take out some of the junk, I only put a half a gallon of chemicals. I have to put in less chemicals to fight against it.
There's no junk.
No, I'm taking out the junk. Right. Let's say I'm gonna make this. Let's say there's rust. Okay, there isn't rust. But let's say there'd be rust. So if I scoop off the rust, I don't have to fight the rust. Okay, the pH is wrong.
The chemicals is to go against the junk.
Correct. The dissolved solid. Yes.
Hard water or something.
Let's say hard water. So if I could scoop that, if I could get that stuff off, I don't have to put in as much chemicals. Okay, so I save money like that. And the other thing is called the bottom blowdown. Well, these are really original names, but they blow down. Again, they take water out of the bottom of the boiler, again, for the same purpose. The same purpose is to get some of the dissolved solids out as a way to make it that the...
But how does it work
less chemical.
in the water tube boiler?
I don't remember. I don't remember how it works. It's a similar idea, but I don't remember how it does it. I'm guessing something I don't remember. Okay, so now, if the water that's coming, if you go to the boiler and take a sample from one of these places, you're not getting an accurate sample of what the water in the boiler tastes like. Because you're getting the most horrible water from the boiler. If you want to see if the water in the boiler is Pegimah, the blowdown water is not accurate to what's really going on in the boiler.
These will lend to being Pegimah, tasting Pegimah.
Yeah, because this is the worst water that's in the boiler. Okay, this is the boiler with the most other things in it. Okay, I shouldn't say it for sure. It potentially has the most Pegimah in it from other things that are not average to what's really in the boiler. So the way if you want to get a real sample is you do what they do. The company, the people who run the boiler, they don't test the water. When they want to see how the water in their boiler is doing, they don't take from the blowdown water because they know that that's not accurate. What they do is they take from a sample station. And the sample station takes water out of the center. It on purpose. It purposely takes it from the center of the boiler instead of from the blowdown water because they know that's more accurate. And extra bonus is that sample stations, b'derech klal, have cooling coils around them, so when the water gets into the container, it's not so hot.
I have never, ever gone to a boiler and had anything remotely like this clarity over here. It's nothing. It's like this. Okay, there's no sample stations, there's no blowdown things, there's none of this thing.
Correct. You didn't know what you were looking at.
But neither do the people that supposedly, okay, not the boiler company, but not the people at the plant that prepare the boiler.
Yes.
Neither do they know what.
Yes.
When you get the dirty water, right? When the first time comes out, it's dirty like anything, and then after a while it gets cleaner.
Mm-hmm.
So is that a right to which where the water is coming from?
It's in the same place. They got to clean it in the same place. You can change places to make it clean.
No, that's still it.
So if he did a bottom blow down, so the first chunk came out, and then he just got, so to speak, better water came afterwards. So yes, I know maybe you haven't had that experience. I have gone to boilers, and
Maybe you had a boiler company.
yes, of course. No, not a boiler company. No. If you take the quality person
The quality person's in charge of the boiler.
hasn't a clue. But the boiler guy, the guy who has a wrench in his back pocket, the guy with the wrench in his back pocket, that guy, when I say to him,
I'm not a plant guy.
no, he's
Plant guy that takes care of the boiler.
But if they outsource it or not?
No. Yes. Every plant's got a guy in the there who walks around with a screwdriver. Okay, that guy who walks around not with a pad of paper, the guy who walks around with a screwdriver. That guy, when you say to him, "I need it from the sample station," know exactly what you're talking about.
Hasn't been my experience.
Okay, fine. So we have different experience.
And if he knows, doesn't mean he's going to give you that the sample. He's
Okay.
going to give you whatever it's up.
Okay.
I'm saying the person at the plant that's going to charge of the boiler don't know a whole lot.
Okay.
They know what the minimum they need to do, take care of the boiler, and then anything else they have the boiler company come
Okay. So
maintain it.
okay, fine. Okay. Now, so that's just if you take an example for Pegimah. And now, our next thing you have to talk about is what I mentioned at the beginning, that sometimes we use boilers to make food Bishul Yisroel. By lighting the boiler, that's our other part. This has to do with the steam being Pegimah and I'm sorry, steam carrying time back and forth. The other thing we do has to do with to make the food Bishul Yisroel. So what is the Mashiach? What do we want?
Let's
So,
say after the pictures. Where the pictures does it in the middle?
Excuse me.
Top and bottom?
So if you put in Bitrix, it will be put into the DA tank. They don't put it right into the boil. No one puts things right into the boil. You put it into the DA tank with other chemicals, gets put into there. So it will be mixed with everything.
You know any companies with Bishop's and boilers?
Yeah.
You do?
Yeah.
In the boiler?
Yeah.
Which one?
So you don't have to say it out loud. Okay, so
They have fast water.
the it would go with it goes in the DA
Zero
tank.
companies have companies with plenty of companies with Bishop's, none of them Bishop's in the boiler.
Okay, so
Not
for today. it's not for today. That's not today's question. All right, okay, let's continue. Okay, so now the in order to make say that the Mashgiach did something or the person did something to make it Bishul Yisroel. So the goal here is, and it could sound silly, the goal here is that a fire needs to be off, and then you do something that makes the fire be on. What I mean is to say is turning a dial that raises or lowers the set point, make it higher or lower. If that doesn't make the fire go on, you haven't done anything. Okay, let's say, imagine think a home oven. It's easier to understand. In a home oven, let's say it's set for 350, and the fire is burning away. The fire's on because the food is cooking, and you said instead of 350, you turn the dial and you make it 400. Okay, you haven't done anything.
What's that? If the fire was off.
I said, and the fire was on, and the fire is on. Then you turn it to 400, nothing happens. But if the fire was off and you turn it to 400, then it says, oh my gosh, got to turn it on. Now, but that also, if you turn it to 400 and you right away turn it back to 350, you didn't have time to catch that it has to go on. So you have to do is make it that the fire was off, and now after I did something now, and I wait and I see the fire goes on. Yeah, it's the same thing. So now that means is if the fire is on right now, that means I have to get the fire off. I got to turn the fire off, wait till it goes off, and then do something to wait till it goes back on. If the fire is off, then I could do something to try to make it to go on. Okay, so what I'm trying to do is I have to see fire off. That's the first step. And then, or do something to get it to be fire off. I see no fire, and then I do something else, and I wait to see that fire is on. Okay? And here...
Okay. When you do that, it only helps. Let's say it was 350 and fire is off. You put it at 400. Now it's going to go.
And you wait until the fire goes on.
Beautiful. That only helps for this run.
But...
Because the adventure is going to go off, and then they're going to overload to 350. They don't want to keep at 400 for the whole night of blood, right?
So that's not really for today, but no, it's not true, because you're a mashlich kisem. I put a heat into
Yeah,
it.
run. But in 2 weeks from now,
When they turn the fire off?
no, they're going to keep it till 350.
No, because I so the didn't say as long as it stays hot. Doesn't make difference. It doesn't have to be my kisem that has to be on. As long as the oven stays hot, it's good enough. So it's good enough.
It's
Okay.
going to say.
Well, how is it off? You turned it off, or it was off because it didn't need to be running at the time?
When you make the
When
Bishul
you
Yisroel,
make it for-
it doesn't make a difference.
No, because if it just happened to be that
No,
way.
it's for 2 days in a week, what it means.
No, if that's the cycle, that it just turns off by itself.
Yeah,
so then-
it does. Of course it does.
So then it'll turn off again, and then...
But that's what he just. But as long as it stays hot, as long as the chamber stays hot, it's the Bishul Yisroel
that's not-
continues.
You wish chamber.
Yes.
Not the boiler. The chamber means the chamber. When
Right.
No, it doesn't. But that is really off topic. So just for you to see, this is if I.
Okay.
Okay, so this is. Yeah, so this you could watch this over here. So here's this is turning on. That was actually me turning on the switch, and that's the sight glass in the boiler. I forgot to tell you what the sight glass is. Okay, the boiler has a sight glass, and you can see the fire inside of it. Okay, you could see the little port that you could see what's going on. And if you watch here in the sight glass, and thankfully my hands are not steady, that's why it's moving around. You see, and you see it's starting to come on. Okay, it's starting. That's
Maybe
the.
I could hear it anyway.
It's starting to come on, and
Yeah, it's all fine.
And there we go. Now, that was the pilot, what they call the pilot, and now it's on for real, okay? So now it's gone from being off. It took a few seconds because it goes through some steps before it actually turns on. It's not like turning on a light. It takes a few seconds to do some things. And some of those noises that you hear is it has to evacuate air. It has all the kinds of stuff it has to do. But if you wait a couple of seconds, okay, what it take 30 seconds over here, then it actually goes on. Okay, it takes a few seconds and it went on. Okay, I actually think that was. I'll tell you if it was. Okay, yeah. So. Okay, the last thing I just want to say is that in all these things, in all these ways of making Bishul, we talk about that in these ways of making Bishul Yisroel, all need oversight, need Hashgachah, which is to say is that I told you at the beginning that in a boiler, in a big boiler, will stay on for months on a time. They wouldn't turn. It's not kedai for them to turn it off, but just because it's not kedai doesn't mean it doesn't happen, doesn't get turned off. So someone's got to keep an eye on it, okay? Someone's got to keep an eye on it. And if it's a small boiler that they taka turn off, then for sure. So in small boilers, where it gets turned off all the time, either someone's lighting it all the time, or there's some kind of a chain system to light it.
Hey, think about your house. Your house is a small boiler. Multiple houses can stay on for years.
Right. Right, but in the factory, so in factory first, so once a year it goes down for inspection. It goes down for an inspection. But something goes down for other reasons. Let's say that something breaks, a part breaks. They have to turn it off. They have to fix it. Okay, so you have something to keep an eye on. So the truth is, it doesn't go down often, and the truth is, self-bishul is mutter. That's not really our issue, but really our hashgachah job is to keep an eye on it. Okay, so the chain system works for some kind of places. It works, and we have used, a little bit have used, a way that monitors something remotely. Okay, it doesn't always work, but what it does is,
I can talk to you about mine.
mine's also not working. It's okay.
No, mine is working. Mine.
Oh, good.
Is the new one your shtickle?
This is-
the regular.
Yeah, but like,
This is that you use, and which is that it keeps.
company, but it's remote.
It keeps track of the temperatures, and the one in this chart. So first, this is a chart for the whole month, but really it has a thing that it can give you warnings also. Okay, when you tell it, I want it to keep the temperature between this and this, and if it drops below a certain temperature, it sends you a warning that says you should just know drop below temperature. Now, you should just know this chart that you see here, this is what we call a log tag. This log tag is not in the boiler. Okay, we're not so fancy to stick things into the boiler, but the point is this log tag is put in the boiler room, right near the boiler. Okay, the sensor is right near the boiler, and you get a sense, like, look at the temperatures here. They're like 100, 150 degrees over here. Okay, the boiler is way hotter than that. But the point is, when the boiler is on, the room is really hot. Okay, well, right next to the boiler is really hot. Even the outside of the boiler is really hot. When it gets, all of a sudden, it drops to 70 degrees. Okay, you see some of those places that drop down really low. You say, hey, something's going on over here. What happened that it dropped down over there? And then either because they turned it off or they have to answer for it.
We were able to actually put the sensor together. We put the sensor on the, I think it's the pressure pipe.
Okay.
And that is so hot. That was like, it was
Okay.
regularly like 350 degrees.
Fine, well, whatever it is. Okay, whatever it is. It takes, okay, so on my last slide, it's just, thanks, Rabbi Corey Newman and Simchas Munsky and Ariel Stein, who helped me while I was working on this thing, on the Star KNOU. Okay, and that's it.